Hi, this is Mr. Shumway. This video clip is a practice for questions that you might see on benchmark number 2. So Jane and Beth are selling cupcakes and cakes to make money. They sell the cupcakes for $3 and the cakes for $17. In order for Jane and Beth to make at least $490, what is the minimum number of cakes they must sell if they only sell 99 cupcakes? Well, so let's write an equation. So $3 times the number of cupcakes, so 3 times C. If I add that to the number of cakes, should we say cakes is with a K? Okay, so $17 times the number of cakes, those would add up to a total, they would equal in this case $490. And I know that I've made 99 cupcakes, so 3 times 99 plus 17 times the number of cakes equals 490. Well, 3 times 99 is 3 less than 300, so that would be 297 plus 17K equals 490. So solving for K, let's subtract the 297. Ten take away 7, so that made, I had to borrow. 10 take away 7 is 3. 8, whoops, gonna have to borrow again. 18 take away 9 is 9. 3 take away 2 is 1. And that is equal to 17 times the number of cakes. And so if I divide each side by 17, I should solve for the number of cakes. And so K equals 11.4. Well, if we say what's the minimum number of cakes, then you would say, well, that's actually going to be 12 cakes, right? So we're looking at Abigail recorded the amount of minutes that it takes for her to drive to work over the past 10 days. And so let's select the box plot that represents the given amounts of minutes. So let's put those in order. Oh, it looks like they're already in order. So let's do quartiles. So let's cut them in half first. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 on each side, the middle would be right there. And the middle of each half would be 17 and 24. So the quartiles, first and third, would be 17 and 24. So that matches there, does not match there or there, matches there and matches there, does not match there and does not match there. Okay, so we know it's not those two. Now let's look at that median. So in the middle is 21. So in between 20 and 22 is 21. That one does not match. This one does. So the linear function 1 has an equation y minus 5 equals x minus 10. Linear function 2 passes through the points 0, 7, and 4, 0. Sven claims that the x-intercept of function 1 is 10, and the x-intercept of function 2 is 4. So the positive difference in the x-intercepts is 6. Decide if he's correct. If he's correct, enter a 6. If he's incorrect, enter the correct positive difference in the x-intercepts of the two functions. Well, let's go ahead and solve this one. Well, when we're talking about x-intercepts, then y is 0. So we have 0 minus 5 equals x minus 10. So let's solve that thing for x. Let's add 10 to each side. 0 minus 5 is -5, plus 10 is 5, x equals 5. And the x-intercept on this one is over 4 up 0. And so the difference between those two is 1. And he says the difference is 6. We say that's incorrect and we enter a 1. Ellie has a set of nickels and quarters. She has a total of 89 coins worth $7. She sets up a system of equations to model this situation. One of the equations is 0.5x plus 0.25y equals 7. The other equation is x plus y equals, well, this one says the number of nickels times 5 cents and the number of quarters times 25 cents equals 7. And so those two numbers of coins we say is 89. She only has 89 coins. Mike is doing a duathlon, which consists of a 7-mile running portion and a 22-mile biking portion. Enter an equation that shows the pace in minutes per mile that Murphy needs to run, as well as the pace in minutes per mile that he needs to bike in order to complete the duathlon in 290 minutes. Well, this 22 minutes times the number of 22 miles times his rate of biking would give us the minutes for biking. So the other portion would be his rate running. And so we say his rate running is 7 miles per hour. So that blank would have a 7. Select the histogram that represents the given weights of a group of dogs. So let's put those numbers in order. Oh, yeah, so we have a, let's see, there's a 29. Oh, there's a 24. There's a 42 and a 47. There's a 53 and a 54. There's a 65 and a 72. And there is an 82 and an 86. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And so let's see. This graph has 1 from anywhere between 0 and 10. So we know it's not that one, because we have nothing below 24. This one has 2 in the group from 20 to 30, and we have 2 in that group. That could be that one. We don't have any in the group between 30 and 40. That matches. We have 2 in the group from 42 to 45. That matches. 2 in the group from 50 to 60. That matches. 53 and 54. 1 in the group from 60 to 70. It's looking like this one right here. So that's just a few of the questions you might see on the benchmark. To practice that, you might want to grab a partner and the two of you team up on one computer. It'll give you some questions. Some of them will be like that. Some of them might be a little bit different. There is another set of practice problems on the next video clip.